Hey, welcome back. So now let's do one more exercise. This exercise is about HSE measurement. Write a program to switch HSE as system clock and measure it. So we know that by default HSI is the system clock, right? Now let's switch it. So this is a procedure to do that in Discovery Board. Now the first step is you have to enable the HSE clock using HSE on bit in this register. And once you turn on the HSE, you have to wait until HSE clock from the external crystal stabilizes. So this is required only if the crystal is connected. So that is in the case of Discovery where the crystal is indeed connected, right? So there is one bit in the RCCCR register which indicates if the high-speed external oscillator is stable or not. You have to proceed only if that stabilization is successful. After that, you have to switch the system clock to HSE. This can be done in this register, RCCCFGR register, and then do your MCO1 settings to measure it, what we discussed in the previous exercise. So now this is a procedure for Discovery. If you are using Nucleo board, then you don't have external crystal connected, right? So in that case, you have to enable the HSE bypass bit because we are bypassing from the external source, isn't it? So you have to enable HSE bypass bit in the RCCCR register. And after that, enable the HSE clock using HSE on bit and then switch the system clock to HSE. Let's do this exercise. Let me create a new project for this. So I just created the project HSE measurement, and here I have listed the steps for the Discovery board. So I'll be coding for the Discovery board here. And the first step is enable the HSE clock using HSE on bit in the RCC control register. Let's go to the RCC section and explore the very first register, that is the RCC control register. Here you find the bit HSE on. So this must be turned on in order to enable the HSE clock. Now its offset is 00. Let's include that in the code. So I'm going to create another offset here. Define RCC CR reg offset. This is 0x00. And after that, let me define one more macro, RCC CR reg ADDR. So let me copy and paste this code here. Let me change this offset to CR offset. Let me create one pointer variable, uint32 underscore t star. So it is actually not required to create the pointer variable. You can directly do the pointer manipulation, but just for understanding purpose, I'm creating pointer variables. So p rcc cr reg is equal to uint32 underscore t star, and this is the address. Fine. And here we have to enable HSE on, isn't it? So enable means set or is equal to 1 shifted by HSE on, that is 16th bit. So let's explore the 16th bit. So 16th bit HSE clock enable, set and cleared by the software. So it has to be 1, right? So 16. So first step is over. Now the second step. So second step is wait until HSE clock stabilizes. So there is a HSE ready flag. So you have to wait until this becomes true or 1. When it becomes 1, that indicates that HSE oscillator is stable. So you have to use this only if you are using oscillator or crystal. So now let's wait until it becomes 1. So we can use the while loop, while. So now let's again dereference this pointer and test for 17th bit, right? So to test, we use bitwise AND operator, right? So 17th bit, right? So that's why I'm going to give semicolon for the while loop. So now let's keep all these things in another parenthesis, right? And here you have to give a not operator, isn't it? Not of this. So suppose if this value is 0, then the stabilization is not yet over, right? So hence this expression will give us 1, isn't it? And while loop hangs here. So when this becomes 1, that means stabilization is over. So this whole expression becomes 0, and then the while loop terminates. And after that, switch the system clock to HSE. This must be done in RCC CFGR register. Let's create another pointer variable and initialize this to CFGR address. Let me change the variable name RCC CFGR reg. So now let's explore this register. So let's go to the RCC CFGR register, and here you have to take a look into SW0 and SW1, that is bit position 0 and 1. Let's check that. So here it is, system clock switch. So if it is 00, then HSI oscillator selected as system clock. If it is 01, then HSE is selected as system clock. So that means bit 0 has to be 1 and bit 1 has to be 0. Let's do that. So for this case, all I'm going to do is I'm going to keep bit 0 as 1. So what's the reset value of this? Let's check that. So the reset value of this register is 0. So I'm going to dereference this point and set, right? So that's why bitwise OR is equal to 1 shifted by 0. I'm going to keep bit 0 as 1. I'm going to set only the bit position 0. And after that, do your MCO1 settings. So this is step 4, sorry. So we can copy the code from our earlier project. So we would need this, right? Configure MCO1 bit fields to select HSI, right? So we would need this code. Let's copy this code. We need all these codes. So let's copy that. Let's go to main and let's paste here. So don't worry, I'll explain this. Let me remove this. All right, so let me give some headings here. So the first step is configure RCC CFGR MCO1 bit fields to select HSCS clock source. So now let me use this pointer here. So here you should not clear now. It is something different. Let's explore that. Let's explore 22 and 21. So for HSC, 22 bit position has to be 1, right? So we have to set the 22nd bit position to 1, isn't it? Let's do that. Set. Let's use bitwise OR. I can just do this 1 shifted by 22, right? So clear 21, set 22. So anyway, 21 is already cleared, or you can clear both the bit fields and then set 1. So that is also fine. That would be the best method, but I'm just skipping that step. And after that, configure the prescaler. So this prescaler configures the divisor as 4, right? So divisor as 4. Let's keep this code. Let's not change this. Let's only change the variable name. And after that, these settings should be same, right? I don't think we need to change anything here, right? So this is the alternate functionality configuration code, isn't it? So it must be same. That's it. Let's measure it. So we must be seeing 8 divided by 4, right? So 2 megahertz of clock at the output, right? Let's try this. Right. Let me run this code. Code is running and let's stop it. So here it is. It is hanging here. That means the stabilization is over. The code is not hanging here. That's great. Let me again run this code. The code is running. Let's get the samples. And here it is. It is 2 megahertz. That's great. So we successfully switched the system clock from HSI to HSC, right? So now the system clock is running with 8 megahertz. So that means your processor is also running with 8 megahertz of clock. So try this at your desk and let me know if you have any questions, and I will see you in the next lecture.